Join me as I dive into the latest FreeRTOS kernel updates for the Raspberry Pi Pico 2 and see if I can get the new build process and using FreeRTOS's own repos to work. In this video, you'll learn about the latest FreeRTOS kernel updates for the Raspberry Pi Pico 2 and what they mean for you as a developer and for makers alike. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT and other fun tech. Remember to subscribe and join the community. Raspberry Pi gave us their own fork of FreeRTOS kernel when the RP2350 was launched, but they are moving back into the fold. FreeRTOS, though, have changed things there in the way that they support third-party chips, like the RP2350. So this makes for a slightly ugly upgrade, to be honest. One of the main reasons for this is that Raspberry Pi fork was designed specifically for the RP2040 and RP2350 chips, giving them direct control over the release. When they started moving back to the FreeRTOS repo, then things have to be agreed across the two organizations. To make things easier, FreeRTOS has split out the third-party support into its own repo. This means that some things have moved around. Let me take a look. If you like this video and it helps your learning or projects, then why not drop me a cash tip using that super thanks button below the video, or there are payment links in the description. I'm using these to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and I'd of course love to meet you all there too. Thank you very much for watching. Please do like and subscribe. FreeRTOS is a real-time operating system. It gives your Pico 2 the ability to run multiple tasks on just those two cores. That of course means that there's a scheduler running there and you can actually prioritize the tasks, so some tasks are higher priority than others. The tasks can communicate and protect resources using semaphores, or send messages to each other using queues or messages. And of course you can either run this on a single core or dual core using the SMP, symmetric multiprocessor capability. If you want to know more about FreeRTOS and using it on things like the Pico, then why not check out my course over on Udemy. That focuses on the Pico and the RP2040. This video is sponsored by PCBWay. For over a decade, PCBWay have been striving to be the most professional PCB manufacturer for prototyping and low-volume production work in the world, making R&D work as easy and hassle-free as possible for makers like you and me. PCBWay site guides you through the PCB ordering process and options. It then keeps you up to date on the order process until the PCB is safely in your hands. Of course, they also assemble your PCBs, do 3D printing, CNC manufacturing and sheet metal work to help your projects too. So why not go and check out PCBWay, after this video of course. For the Pico 2 and indeed RP2350 launch back in August, then Raspberry Pi produced their own special repo and clone, fork if you like is the right term for it, of the FreeRTOS kernel, and that was on their own GitHub space. And I've been using that for a while now. It's certainly been the stable and it is the way I provide FreeRTOS in a lot of my applications. But now here we are in the end of February 2025 and that repo is being deprecated. That actually means it's stable and completely usable, but it is not going to be pushed forward or no future bug fixes or capabilities are going to be rolled into that. Instead, we're actually going back to the standard FreeRTOS kernel. Now that is good because I thought it was a little bit odd that they'd actually forked this in the first place, but I can understand why, and it's about being in control of the launch for the RP2350 and be able to put everything out on the same day in synchronization without scheduling that too much across lots of different bodies. But FreeRTOS themselves have got their own plans for how third-party chips like the RP2040 and 2350 are going to be supported, and that makes this a little bit more lumpy and complicated than it was going to be, because not only are we talking about that FreeRTOS kernel repo, but now all of the code for third-party chips like the RP2350 is in a separate repo, the FreeRTOS kernel community support port, but that repo is actually linked as a submodule into the FreeRTOS kernel. How that's quite going to work across releases, I'm not quite sure, because the relationship for those would be sort of fixed at a release point. Yet you would think the community support ports would want to roll forward a little bit beyond the release version. So we'll have to wait and see how exactly this is going to work. Right now, it isn't in any release version. So the most recent version of FreeRTOS kernel is version 11.1.0. That does not contain any of the RP2350 port code in the linked version of the community support port. If you want that, and that's what I'm going to use in this demo, in this video, well, then the only way is to use the head of the repo at the moment. And that's okay for development purposes. I must admit, if I was releasing code for a client and writing code for a client, then I would be going to a numbered release version, because I would want to know that it is stable. I would want to be able to track back to what bug fixes are going to happen, and also to be able to document and inform the client which version I've used and when we're likely to want to do upgrades and patches, etc. So let's have a quick look and see how all of this hangs together. So here we've got the FreeRTOS kernel repo over on GitHub, and it's got all the description information down the bottom there. I want to just show you where things are now in terms of portability for the RP2040 config. Now, the everything is in the portable folder, and then as things were in the old days, we used to go into third party, and in there in GCC we will still find support for the RP2040, i.e. for the Pico. But actually for the RP2350, they've got a new place for this. So if we go back up to portable, and sorry, I've gone a bit too far up, we still want to be in third party, but there is now a new linked repo in here called community support port, and it's in there that we're going to find our support for the RP2350. So I'll drill in there, and here we go. We've got support for the RP2350 for the ARM cores or for the RISC-V cores. Just have a look at the ARM cores, because the one file I want to point you to in here is this FreeRTOS kernel import.cmake file, because it's that file you want to copy out into your project in order to start the build process and include into your CMake. And that's what I've done in mine, and it's this one that then understands where to find all of the source and how to build a version of FreeRTOS kernel for the RP2350 in single core or dual core SMP mode. So there you go, that's where those are. So I'm going to demonstrate this using a little project to calculate the value of pi, and this sort of fits in nicely to celebrate Pi Day on the 14th of March. So my pi application is basically going to calculate the value of pi to 1,000 decimal places and see how many times it can do that in a minute. So it's a bit of a performance test for a Raspberry Pi Pico 2. And I'm going to have two versions of that, one that's going to run it across a single core and one that's going to run it across two cores. To be honest, the code for this is actually identical. It's just the configuration of FreeRTOS that's going to change that. Well, I suppose the second core one, I do run slightly more worker threads, but pretty much the code is identical. All my code for this example can be found on GitHub, and I've put it in this repo here. You notice this is under my Dr. John EA organization space. This is going to be the new place for me putting code that I intend actually maintaining rather than just point-in-time experiments. Now, I've put the FreeRTOS kernel code in a library. It's a shared library actually between the two examples, but it's a library within this repo. And I've done that by making it a submodule. Now, that's slightly painful because you've got to first of all clone the FreeRTOS kernel into your library using the git submodules add command. And then after that, you've got to then go into this portable third-party community supported ports folder and then actually cause that to update and pull in by using the command git submodules update --init, which is a little bit of a mouthful. So this is a slightly painful process, I think, to adding the FreeRTOS kernel and getting it actually into your as a submodule into your repo. But that's the process you sort of need to go through, and that's what I've done. The alternative, I suppose, is to have a shared version of FreeRTOS kernel out as a shared folder that you could actually just link to via an environmental variable. There are swings and roundabouts in doing that, and I'll rant about that in another video perhaps. So the two projects are within this one repo example, and I'm sharing the library folder. So I've got one copy of the FreeRTOS kernel here, and down here in portability in third party, we have the community support, and you see I've used git to cause that all to pull in, and so we've got support for the RP2350 right the way down there. I need one other library for what I'm going to do, a library called Pi SPI got, which is what is going to actually do the calculations of pi for me to 1,000 decimal places. Not that I could do the maths myself, so fortunately someone else has written the library for that. So then we've got two projects, one RTOS and two RTOS. One RTOS is single core, two RTOS is running across both cores. Really, I just want to show you the make process for this because firstly, I've got the FreeRTOS kernel CMake file that I was talking about coming directly from the FreeRTOS kernel library, and I've actually copied that there because it just makes it a little bit clearer to me what's going on, and that's then being included. I am giving it some environmental variables of where to find my FreeRTOS kernel and its path and that shared library for it. And I've also got a FreeRTOS configuration here because I used my standard approach of having a port folder with a port configuration for FreeRTOS. So that's saying which bits of FreeRTOS I want to load in, how I want memory management to work, and some of the additional libraries pieces I need for that. If you want to know more about that, then I recommend having a look at my Udemy course. The code itself is really just going to start up a FreeRTOS, which is what these functions are doing, and then it's going to start up two worker threads, which are basically going to go and do the calculations. So they're both actually going to do the calculations, and then it's going to keep counting how many times it's managed to calculate the value of pi until the alarm goes off. That's fairly simple. And I've got a little bit of code here for the workers, which is actually going to do the clever bit of maths to calculate the value of pi. And then the counter, which is actually going to count up the results. And when the timer goes off, it's going to print the results and stop counting. So that's all the code is. And the code is going to be almost exactly the same for two cores. In fact, the only difference there is I'm going to run up more workers. So I'm going to run up 4 workers now. And then 2 workers, so that these workers will then switch around on which of the different cores they're running across. I'm not fixing any of the workers to a particular core, so the scheduler will just place them on cores as it's available. And then the count code is the same here. So let's have a look at the results. So I'll demonstrate this on a single core model, and we can get through 380 calculations of pi to 1,000 decimal places in a minute. And that's spread equally across those two worker tasks that I've actually got. In dual core, we can get through a bit more, actually 627 calculations, but they're split slightly unevenly across the two cores. There's a little bit more work going on to core 1 than core 0. That's because core 0 is doing all of the counting work. Right now, I feel a little bit in limbo as which version of FreeRTOS to use. The new direction is definitely the FreeRTOS repo, and of course the community support repo that goes with that for the RP2350. This isn't all wrapped up in a consistent FreeRTOS release though. Well, not quite yet. If I was writing code for a client project, I'd probably still drop back to using the Raspberry Pi fork right now, even though they have deprecated it. In fact, being deprecated means it's stable and therefore usable in my projects. For forward-looking projects then and my own work, then I'll probably move to using the FreeRTOS release and take the risk of using the head of the repo, which of course can be unstable. Don't forget to leave your thoughts in the comments and check out my other videos for more Raspberry Pi Pico tips and tricks. If you like this video and it helps your learning or the projects, then why not drop me a cash tip using that super thanks button below the video, or alternatively the payment links I've put in the description. I'm using these to get myself to the open source conference in San Francisco, and I'd appreciate your help in getting me there, and I'd love to meet you all there too. Thank you very much for watching. Please do subscribe and like the video. I really appreciate it. Bye bye for now.